There's some properties of logs that we need to be aware of. The first one is the base. When we look at the base must be positive and not equal to 1. And there's a very good reason for this. If we take a look at a base, so for example, let's say the base is -2, and we do power 2, well, that's easy. That's going to be positive. If I do power 3, that's going to be negative. Okay, no problem. Now, if it's odd, it's negative. If it's even, it's positive. Now, we run into a problem when we do something like this. And since the exponent is defined for all real numbers, if I put pi there, we don't know what the answer, if the answer is going to be positive or negative, because pi is neither odd or even. So there's a problem. And so we cannot define this exponent, pi. And because we want to define the exponents for all real values, not just for integers, we need to say that the base cannot be negative. The other problem is if the base is equal to 1. We end up with 1 to the power of x equals y. Well, that's okay, because that just means that y is always equal to 1. However, when we put it into log form, okay, base 1, well, if I put x as 5, then there's no way that I can get an answer for this. Log base 1 of 5, well, that's not true because we know that any base 1 is going to give us an answer of 1. So this runs into conflict. So we're not allowed to have base 1 either. So the log of the base, or so the base of the log, must be positive and it cannot be equal to 1. The other two are just definitions. Okay, these are identities. And there's a few different ways we can understand this identity. So I'm just going to look at the first one here. And we have our base, we have our argument, and we have our exponent. And I can just rearrange this using the definition of log, base, exponent, and that's going to be equal to the argument, a to the power x, and really it's just an identity, right? It's just going to give us an equality, so this is true. And we can then say that whenever we see this expression, we should always just simplify it to x. Another perspective for this is we can just use how we should understand logs. Okay, logs is really just the exponent on the base. Okay, so I've got the exponent on this base that gives me this answer. Well, by definition, that answer, the exponent on this base here, must be x. Okay, so we can kind of do it as how we define a log. Thirdly, we can justify this statement by using the log, we can use the property that log and exponents are opposites, so they must undo each other. So I have an exponent, I have a log. Well, they must undo each other, and I must get the original input that was x. So one undoes the other. So we can have three different ways to justify this identity, but in the end, this is an identity. We should know this identity. We can take a look at the other one as well, and we can justify that identity down here, kind of using the same perspective. So looking at it from a definition of log perspective, there's my base. Okay, so here's my base. Here's my argument, and here's my exponent. And I could rewrite this using the definition of log. Log, I'm going to start with my log base A of the argument x is equal to the exponent, which is log base A of x. So again, based on definition of log, we can rewrite it and we can see that this is an equality. So we know anytime we see this expression, we should always make it equal to x or simplify it to just x. We could also justify this from the perspective of what a log actually is. The log itself is an exponent. It's exponent on this base that gives me the answer x. So if I put this exponent on base A, I should naturally get the answer x. So that's the second way we can justify this. The third way, again, is like what we did before. Log and exponent undo each other. We have a log and we have an exponent. Well, if we have a log and exponent, they undo each other. So our input x should be our output x. So these two statements. Really, we don't need to justify these two. These two statements really should just, in the end, we should be using these as an identity. Anytime we see these two statements, we should just simplify it to x.